MOTS-c is a peptide that your mitochondria make when stressed. It drops body weight in obese mice by 20%, it increases endurance performance in mice by 50%, and it partially mimics fasting and exercise. And truthfully, with these results and its interesting mechanism, MOTS-c might be the closest thing we have to exercise in a vial. So today, we are covering everything you need to know about what is probably the most powerful mitochondrial peptide. We're talking the mechanisms, the studied effects, the theoretical safety concerns, and who might benefit from it if it were approved by the FDA. And then, as always, we're getting super practical, covering the hypothetical best form, dosing, frequency, timing, and cycles. Let's jump in first with the mechanism. So, as we talked about in our video on SS31, there are two main groups of mitochondrial peptides. One are the mitochondrial targeted peptides. These are synthetic peptides not actually created by your own mitochondria, but were synthetically created to target certain parts of the mitochondria to improve their function. And that's where SS31 falls. The second group are mitochondrial-derived peptides, meaning they're peptides that are derived from human mitochondrial DNA. And this is where MOTS-c and the less popular humanin fall. And before we go into depth on how MOTS-c works, here's the simple version. MOTS-c tells your cells that you're under stress, and then it helps them adapt to that stress and any future stressors. It increases mitochondrial health, makes you more efficient at burning glucose and fat for fuel, increases your antioxidant capacity, and improves metabolic flexibility. But now we have to break down how it actually does that, because these particulars are going to be super important when we get practical on how you could actually take this one. So MOTS-c stands for mitochondrial open reading frame of the 12S rRNA-C, which basically means it's a peptide that is produced from that specific region of mitochondrial RNA. Basically, your mitochondria have their own DNA, and that DNA is used to create mitochondrial RNA, which is then used to create mitochondrial-derived peptides or proteins, i.e. the 16 amino acid long MOTS-c. And this process of MOTS-c creation is increased in your cells under times of metabolic stress. Essentially, MOTS-c will be increased in times where you have less glucose available, or you have oxidative stress, or with exercise, or even with just mitochondrial dysfunction. And with this increase in MOTS-c, what the mitochondria are basically trying to do is signal to the rest of the cell, hey, we're in trouble, we need help. And MOTS-c's role is to act on multiple cellular pathways to provide this help. It partly does this by going into the cell's nucleus to activate something called antioxidant response elements, essentially allowing the cell to increase its own antioxidant support to fight against that oxidative stress that might be happening. But chiefly, outside of the nucleus, MOTS-c regulates very important metabolic pathways. Specifically, it modulates something known as de novo purine biosynthesis and the folate cycle, which will be super important when we talk about risks later. But this modulation results in buildups of intermediates within this cycle, and that buildup of intermediates then activates something known as AMPK, which is the cell's master energy regulator. Then downstream, AMPK also activates sirtuins and PGC1 alpha. And AMPK, SIRT1, and PGC1 alpha all work together to improve mitochondrial function, create new mitochondria, stimulate glucose uptake into the cell, and increase the utilization of fat for energy. Furthermore, this AMPK, SIRT1, PGC1 alpha pathway also inhibits something called NF-kappa B, which due to this, there's then less inflammation and less oxidative stress. So basically, through all these signaling pathways, MOTS-c is one of your body's natural ways to get back to homeostasis or proper balance after times of stress. And this is because MOTS-c is triggering your cells and thus your body as a whole to better upregulate its ability to produce antioxidants and increase its metabolic flexibility and better regulate inflammation. And interestingly, the next time that your body or cells get under stress, they'll be better able to handle that stress due to the past actions of MOTS-c. It's basically like coming back stronger after you work out and then recover. And in this case, it's something called Mitohormesis. And all of that is how endogenous MOTS-c, or the MOTS-c your body creates, naturally works within the cell. But by knowing that, you can probably understand how exogenous MOTS-c, or using it as a peptide therapy, could really provide some pretty promising benefits. Essentially, by taking MOTS-c, you are simulating that adaptive stress response from your cells. You're basically telling them, hey, we need to be able to increase our ability to produce antioxidants and better improve our ability to burn fat for fuel and increase insulin sensitivity and improve our mitochondrial function. That way, when we have a stressor in the future, you are better able to respond to it and get back to homeostasis. And if you're deep into the longevity space, that mechanism might sound familiar to you because some of the benefits from fasting and exercise come from a very similar mechanism, which makes sense because, as I briefly mentioned, exercise itself increases MOTS-c, and multiple studies have demonstrated this. And that is why MOTS-c is often referred to as exercise in a vial. But now that we understand how MOTS-c works naturally, let's talk about how researchers have tried to optimize it for medical use, and that is through the creation of its analog, CB-4211. CB-4211 was made by a drug development company known as Cobar, and they note it to be a novel synthetic analog of MOTS-c. We do know that it has an extremely similar structure to MOTS-c, but because CB-4211 is a patented drug, it does have to be different than the native MOTS-c. And although the exact differences aren't publicly known, because the patent covers many different structures, we can hypothesize that what they probably did was changed 1 to 2 of the amino acids out of the 16 amino acid structure of MOTS-c to better improve its stability. And then there were likely additional chemical modifications made to further improve half-life and bioavailability. But these small changes likely did not change the core mechanism of action of the MOTS-c sequence. Rather, the changes were more likely just working on allowing MOTS-c, or CB-4211, to actually get to its site of action within the cell. So while we can't with 100% certainty translate all the research from MOTS-c to CB-4211 or vice versa, we can be fairly confident that they will have pretty similar effects. And this whole discussion could become increasingly important based on the regulatory landscape of MOTS-c and CB-4211. MOTS-c is currently under the FDA's Category 2 list, meaning it can't legally be compounded for patients right now. So because of this, I'm not currently recommending anyone take MOTS-c. But if CB-4211 becomes an FDA-approved drug, this one could become a good compoundable option for off-label use, just like we discussed with SS31 in our last peptide video. But what are the possible uses of MOTS-c or CB-4211 based on these mechanisms? Well, let's look at the studied effects to find out. First, let's start with what is, to my knowledge, the only human study on MOTS-c or CB-4211, and that is one small phase 1 clinical trial using CB-4211 for non-alcoholic fatty liver disease. For 4 weeks, 11 patients were given Subq CB-4211 and 9 were given placebo. And those given CB-4211 had a 25% reduction in their liver enzymes and a 6% reduction in their fasting blood sugar. And this is super impressive data for the case of MOTS-c or CB-4211 being used for not only non-alcoholic fatty liver disease, but also for weight loss and metabolic syndrome in general, that collection of obesity, high triglycerides, insulin resistance, etc., due largely to its ability to activate that AMPK pathway, which results in all the downstream effects that we mentioned. MOTS-c was found to reduce insulin resistance and significantly reduce body weight in obese mice. Specifically, MOTS-c reduced their blood sugar by 25% and also reduced their body weight by 20% in these obese mice that were fed a high-fat diet. And based on the fact that MOTS-c can simulate some of the effects of exercise and fasting, it makes sense that weight loss and reducing metabolic syndrome could be pretty promising use cases for MOTS-c. But it's important to note that this has not been fully studied in humans yet. And for the rest of the potential use cases we're about to talk about, it has not been studied in humans at all. It's purely speculative based on mechanism and the animal data that we'll walk through. That being said, the next and probably most exciting potential use case to me is using MOTS-c for anti-aging and longevity in general. As discussed on multiple videos in this channel, mitochondrial dysfunction is a root cause of aging itself. So by improving mitochondrial function, it would make sense that MOTS-c or CB-4211 could help inhibit the aging process. But MOTS-c's effect on the root causes of aging doesn't stop there, because based on the mechanisms that we discussed, MOTS-c also has a huge impact on the regulation of energy and nutrient sensing through that AMPK pathway. And then it also works to lower chronic inflammation through that inhibition of NF-kappa B. And then to a lesser extent, it could also positively impact the folding and organization of proteins, cellular senescence, and communication between cells. And all of these mechanisms are working on a hallmark or root cause of aging, which further bolsters MOTS-c's case as a longevity agent. And then what makes it even more promising is that studies have noted that MOTS-c plasma levels fall with age in humans. So theoretically, by replacing this MOTS-c deficiency that occurs with aging, you could be helping stall the aging process. But based on all of this, it's pretty clear that MOTS-c has a very strong mechanistic rationale for its use as a longevity agent or maybe even a lifespan extending agent. Unfortunately, there are no high-powered studies evaluating its effect on lifespan extension, but we do have multiple mouse studies demonstrating MOTS-c's ability to improve health span or improving quality of life and functionality with age. For instance, in one study in a mouse model of aging, MOTS-c was found to inhibit multiple aging-induced changes in the skin, liver, fat, and even just metabolism in general. And then in another study, MOTS-c delivered late in life in the mice was found to not only improve metabolic function, but also markers of body composition and functional strength and movement markers. And when this same study actually looked at the lifespan of these mice that were given MOTS-c, they found trends of MOTS-c improving both average and maximum lifespan by 7%. However, these changes were not statistically significant, partially due to the low sample size. But I definitely think that this shows that a higher powered, larger sample size study should be done looking at the lifespan extending effects of MOTS-c. And regardless, this data and mechanistic info we do have, to me, still gives MOTS-c a ton of promise for use in anti-aging and longevity, even if it were found to not directly extend lifespan. But obviously we would need some human data at all to prove any of these effects. But this potential effect of longevity and health span promotion of MOTS-c brings up another related potential use case, and that is for skeletal muscle health and performance and exercise enhancement. What animal studies have demonstrated is that not only does MOTS-c increase with exercise, but giving additional exogenous MOTS-c prior to exercise will further enhance exercise performance. Specifically, in one mouse study, after only a single dose of MOTS-c, total running time was increased by 12% and running distance by 15%. Then in another study, when young mice were given MOTS-c for 10 days, their exercise capacity significantly increased with higher doses of MOTS-c regardless of the diet they were fed. For instance, with the higher MOTS-c dose, the young mice were able to run 30 to 50% further in a set time, and they also increased their power output. And then every single mouse that received MOTS-c was able to run at the max sprint speed that they were tested at, while only 16% of the mice receiving placebo were able to do so. And then in the same study, middle-aged mice and older mice were also given MOTS-c, and their aerobic and anaerobic exercise performance also improved. But the older mice also saw an improvement in their grip strength. However, the younger mice did not. There are less other studies on strength improvement, and MOTS-c definitely seems to more positively impact those slow twitch muscle fibers, or those that are more involved in endurance performance, compared to the fast twitch fibers, or those that are more involved in maximal strength and power. And this makes sense mechanistically because these slow fibers are much more reliant on mitochondrial function, which is supported by the AMPK activation that MOTS-c provides. And interestingly, in a study looking at a human genetic variant of MOTS-c that has less biologic activity, researchers found that those with this variant, and thus functionally less MOTS-c, had more fast twitch muscle fibers and higher measures of leg strength. And those with this lower MOTS-c activity were slightly more likely to be strength athletes compared to endurance athletes. And then further adding to the story, when mice were injected with a substance made to inhibit MOTS-c, their fast twitch fibers actually increased. So it makes sense that exogenous MOTS-c is more beneficial for markers of muscular endurance when tested in mice, but not so much for maximal strength markers. Thus, MOTS-c has a lot of promise for enhancing any athletic performance that relies on muscular endurance or aerobic or cardiorespiratory fitness. And this is due to that enhanced mitochondrial function. However, improvements there might come with slightly lower maximal strength and power due to having less of those fast twitch fibers. But also in regards to muscle health, MOTS-c also shows a lot of promise for inhibiting general muscle loss due to age, rapid weight loss, cancer, or periods of immobilization. And this is partly due to MOTS-c's ability to inhibit inflammation and inhibit improper fat accumulation. But it's also due to MOTS-c's ability to inhibit muscle catabolic pathways, or those pathways responsible for breaking down muscle. One study, for instance, demonstrated that MOTS-c administered to immobilized mice was able to decrease muscle loss from 15% in the control group to only 5% muscle loss in the group that was administered MOTS-c. And this ability to potentially inhibit muscle loss with age or inhibit sarcopenia is one of the ways that MOTS-c works to improve longevity and health span. And yet another way that MOTS-c could improve health span and promote longevity is through another one of its related use cases, which is inhibiting osteoporosis and improving bone health. Through its activation of AMPK, which also inhibits bone breakdown, and also through different mechanisms which allow it to promote bone building, MOTS-c has also been studied for osteoporosis prevention. Specifically, one study in mouse models of menopause demonstrated that MOTS-c was able to mildly inhibit bone loss. And the potential use cases don't stop there, because MOTS-c has also been studied, although less so, for neurodegenerative diseases. In one study looking at endogenous MOTS-c levels in humans, they found that those with Alzheimer's disease actually had less MOTS-c than did those in the control group, which adds weight to the theoretical benefit of giving MOTS-c to those with Alzheimer's disease to improve the oxidative stress and the mitochondrial dysfunction that could underlie Alzheimer's disease. And when MOTS-c was given to mouse models of Alzheimer's disease, the mice's cognition and memory markers did improve. And similarly, MOTS-c was also found to inhibit brain damage caused by Parkinson's disease in a mouse model. And then our last main potential use case to talk about is using MOTS-c to prevent coronary artery disease or atherosclerosis or plaque production. Similarly to Alzheimer's disease, endogenous MOTS-c levels are found to be lower in those with coronary artery disease in humans. So again, adds a little weight to giving MOTS-c to hopefully inhibit the progression or development of coronary artery disease. And we have very little data though on this use case, even in mice. So this is even more of a speculative use case. But we do have one interventional study noting that MOTS-c was able to improve blood vessel function in mice vessels in vitro, which would mechanistically improve atherosclerosis. So all in all, to me, those are the main potential use cases for MOTS-c. But because improving energy regulation and improving mitochondrial function can help in many, many conditions, the potential use cases for MOTS-c are not just limited to these. For instance, there are studies on MOTS-c improving autoimmune conditions in animal models through these mechanisms we talked about, but also due to MOTS-c's ability to more directly impact the immune system. And then review studies note that MOTS-c might have a positive impact on eye retinal diseases, or even in optimizing hormones, and in improving fertility and ovarian reserve, all largely through this improvement in mitochondrial function. But many of these additional use cases are not even interventional studies in animals, so they're mainly just speculative based on the wide sweeping effects of MOTS-c. But before we can talk about using MOTS-c in any of the use cases we just talked about, we also have to talk about the potential risks and safety concerns of doing so. We've talked about general peptide safety considerations in our other videos, so I'd recommend checking those out. And here we'll just keep it more specific to MOTS-c and CB-4211. And the most important thing to note up front here is that we have very limited human data on either of these peptides. We have no human data at all on exogenous MOTS-c, and we have only one really small human trial on CB-4211. And in that trial, 11 humans were given 25 milligrams of Subq CB-4211 daily for 4 weeks. And while these individuals had no significant adverse effects, this is still not near enough data to actually prove long-term safety. So as always, it's important to theorize what potential risks if we were to use MOTS-c or CB-4211. And again, these risks all go back to the mechanisms that we originally talked about. The first to talk about is MOTS-c potentially decreasing folate levels and elevating a homocysteine level. As we discussed earlier, MOTS-c increases the activation of AMPK through first modulating the folate cycle. And this modulation can deplete folate. And then this depletion of folate can then elevate homocysteine. And unfortunately, homocysteine elevations are linked to multiple disease states, including heart disease and stroke. So to mitigate this risk of MOTS-c, I would recommend doing a few things if hypothetically you still were going to take this one despite the FDA warning that we talked about earlier. First, I would be getting your homocysteine and folate levels measured prior to starting MOTS-c, which I do for all my patients anyways. If you have significantly elevated homocysteine levels at baseline, then this is especially not a peptide that I would pursue. And second, if you were taking MOTS-c or CB-4211, I like the idea of taking methylated B vitamins on the days that you're not injecting these peptides, with dosing dependent on your levels. And there are no studies on this method. This is purely speculative based on the mechanisms, but my thought here is that too much methylated B vitamins on the day of injection of MOTS-c might blunt MOTS-c's effect because it's blunting its ability to modulate that folate cycle. But too little B vitamins throughout the week could result in an elevated homocysteine level, like we talked about. So a good balance here to me is taking the methylated B vitamins on the off days of the injection. And finally, the third strategy here is to really make sure you recheck your homocysteine and your folate levels after you complete a cycle of MOTS-c. If they are too elevated, then I definitely would not recommend repeating any MOTS-c cycles. Then outside of homocysteine elevation, the next main safety concern to talk about is the potential of overstressing the mitochondria. And this one is even more of a speculative hypothetical risk because in all of the animal interventional studies, there was no evidence of MOTS-c causing this overstressing effect. But you can imagine that since MOTS-c is essentially your mitochondria's stress signal, that's also elevated in times of fasting or exercise, that continually pressing this stress signal that is MOTS-c could be too much for your cells to properly adapt to. Think about overtraining with exercise and the detrimental effects that that can cause. While those detrimental effects are through a different mechanism, the general idea still remains for MOTS-c. Essentially, with either MOTS-c or CB-4211, if we continually keep activating that AMPK pathway, we might be tipping the scales too much into the side of the energy sensing catabolic pathways, and we won't have enough of the anabolic growth pathways, such as mTOR. And this would theoretically limit recovery or protein synthesis, both of which are super important for those wanting to maintain or improve muscle mass or strength. Then secondarily, because MOTS-c improves fatty acid oxidation and glucose uptake, this will stimulate the mitochondria to send more electrons through the electron transport chain to make more ATP, which can be a good thing, but if the electron transport chain can't keep up, aka we're overstressing the mitochondria, then some of these electrons will start to leak out and produce more oxidative stress, which can damage the mitochondria and further damage the cell. And again, this overstressing has not been demonstrated in any of the animal studies on MOTS-c. However, we only have one human study on CB-4211 and none on MOTS-c, so we don't really know the dosing or cycles or frequency that could cause this overstressing effect in humans. And we'll talk later on how to hypothetically mitigate this risk by taking MOTS-c in certain ways. However, in addition to how you take MOTS-c, a couple other ways to mitigate this risk. First is that regular lab work should be completed while you're on MOTS-c to make sure that your proxy measures of mitochondrial function don't worsen. And then secondly, you should also monitor your symptoms. If you get more fatigued, you start losing strength in the gym, you lose muscle mass, all of these could be signs that you're overstressing your mitochondria. And finally, to also hopefully help inhibit this potential overstressing, proper nutrient supplementation to assist the mitochondria could also theoretically help. So outside of just B vitamins like we already talked about, I also generally recommend magnesium glycinate, CoQ10, alpha-lipoic acid, and then plus or minus L-carnitine depending on your baseline heart disease risk. So overall, those are the two main theoretical risks of MOTS-c. However, because we don't have really any true human safety data on MOTS-c or CB-4211, we could be incurring additional risks. We really just don't know what its risk for dysregulating the immune system is or for potentially promoting cancer. Although I will say MOTS-c's mechanism would argue against these being true additional risks. But based on all of this data on the mechanisms, the studied effects, and then these theoretical risks, let's have our true benefit-risk ratio discussion to see who might actually benefit from taking this one if it became FDA approved. Well, to me, this one is a potential top-tier peptide for anti-aging and longevity, as it has some of the best preclinical data for Healthspan while also having mechanistically a pretty good safety profile. And you can definitely do both MOTS-c and SS31 for this use case. But if I had to just choose one for longevity, it would be MOTS-c. This is because SS31 only demonstrated longevity type benefit in older mice. Compare that to MOTS-c, like we talked about, had longevity type benefit in mice of all ages because essentially you're using the MOTS-c to better train the mitochondria and train the cell. Compare that to SS31 where you're just more so providing structural support that is needed with aging. And to me, with FDA approval, MOTS-c could be a really good add to an anti-aging longevity stack if you're someone with mild insulin resistance or obesity or any evidence of metabolic syndrome. While the GLP-1 agonists like tirzepatide have a little bit more data here, I still think there's a place for MOTS-c in this circumstance, especially if you're someone only with mild insulin resistance and are more focused on the anti-aging components of peptides. Additionally, I think MOTS-c is a top-tier peptide for endurance exercise enhancement. However, it is worth noting here that MOTS-c is prohibited for use in athletes by the World Anti-Doping Agency. But if you aren't an athlete, could you just use MOTS-c or CB-4211 in place of endurance exercise? Well, I definitely would advise against this. Aerobic exercise provides a very wide-sweeping, broad effect in multiple organ systems throughout the entire body. Compare this to MOTS-c, which mainly provides its effect in skeletal muscle through one specific way of activating AMPK. So you will miss out on a lot of potential benefits of aerobic exercise if you're just using CB-4211 or MOTS-c. However, using them in combo with aerobic exercise could provide synergistic effects better than just exercise alone. And this was, again, demonstrated in multiple mouse studies. So if you care about aerobic or endurance exercise, and if you're focused on longevity, I think you should, then MOTS-c could be a potentially good add. But if you are only focused on strength and power, then I would definitely pass on MOTS-c. And again, this is due to MOTS-c shifting more towards the slow twitch fibers that are better for endurance compared to the fast twitch fibers that are ideal for muscular strength and power. That being said, in times of cutting or more severe caloric restriction, MOTS-c could be beneficial for muscle maintenance due to the mechanisms that we previously described. So to me, those are the most likely populations to benefit from MOTS-c if it were FDA approved. Metabolic syndrome, anti-aging and longevity, and aerobic exercise enhancement. But again, I still think MOTS-c shows promise in all those other potential use cases we talked about, especially for neurodegenerative disease. But if you were hypothetically going to use this one, what would be the optimal form, dose, timing, and cycles? Well, for the form, we first have to talk about MOTS-c versus CB-4211. So while CB-4211 is likely the first one you'll be able to get legally, given that it's already in the drug pipeline, currently its structure is unknown. So pharmacies or producers supplying it are most likely just supplying their own slightly modified version of MOTS-c and then calling it CB-4211. So until the structure of CB-4211 is publicly known, even if you are getting CB-4211, you are likely just getting a very minimally modified MOTS-c. So for that reason, we're going to focus on MOTS-c for the rest of this video. So what do we know about the specific form of MOTS-c? Well, there are no studies looking at topical MOTS-c like there might be for other peptides. And to my knowledge, there was only one study looking at oral MOTS-c. And in this study, they were looking at mice with inflammatory bowel disease. And what they found was that injectable MOTS-c improved markers of inflammatory bowel disease, but oral MOTS-c did not. That being said, a modified, more advanced oral formulation of MOTS-c did provide benefit for inflammatory bowel disease. So while this does provide some future promise for these advanced formulations of MOTS-c that might have some oral bioavailability, the standard MOTS-c based on its structure, does not have any oral bioavailability, and this is exemplified by this study. And furthermore, all other animal studies used injectable MOTS-c, and most of these have either been intraperitoneally or directly into the abdominal cavity or subcutaneous. And then the one human study we have on CB-4211 also used subcutaneous administration. So until we somehow see more studies on this advanced oral form of MOTS-c, I would definitely be sticking to a subcutaneous version for right now. But what's the best dose and frequency of Subq MOTS-c? Well, as always, this is tricky because we don't have any human data on MOTS-c and just one, again, on CB-4211. And in that study on CB-4211, they used 25 milligrams Subq every day, and it was effective and had no significant adverse effects. However, one, it's hard to directly translate this to MOTS-c dosing because we don't even know the entire structure of CB-4211. And two, it's only one study with no long-term safety data. So it's hard to use that study for proper MOTS-c dosing. So for this reason, we have to go back to the animal studies and look at the human equivalent dosing of the doses used in those studies. And to me, based on no published human safety data and the potential risk of overstressing the mitochondria and elevating homocysteine, I like the idea of using the lowest dose that was found to be efficacious in these animal studies. And this dose was actually found in the impressive study on MOTS-c reducing body weight in those obese mice fed the high-fat diet. And the dose they used in that study was 0.5 mg per kg per day intraperitoneally. So when we convert this to a human equivalent dose, accounting for the fact that we also have to transition it from intraperitoneal to Subq dosing, we get about 0.048 mg per kg per day, or for an average 70 kilogram adult, 3.33 mg per day, or 23 mg per week. But should you actually take it every day? Or should you split that 23 milligram weekly dose into slightly larger doses done less frequently? Well, again, this is tricky because of limited data. Because unlike other peptides we reviewed, we actually don't have any pharmacokinetic or pharmacodynamic studies on MOTS-c, meaning we don't even know how long its half-life is or how long its effects last within the cell, which again is even further reason to dose this one pretty low, given we just have less knowledge of its effects. So on the same token, if we're trying to mitigate the risk of overstressing the mitochondria or elevating homocysteine, I think there's a lot of mechanistic basis to do this one less frequently than every day. This would allow us to essentially provide that stress signal that is MOTS-c, and then allow our cells ample time to recover and adapt and give us the potential benefits that we discussed. And this would also give us time to replenish our B vitamins and lower our homocysteine on the non-injection days. And furthermore, this less frequent dosing has been studied in mice. Specifically in that main anti-aging study we discussed, they used 3 times per week dosing in the older mice that were found to have improved markers of Healthspan and a trend towards improved lifespan. So while many animal studies use the daily dosing, I really like the idea of doing 3 times per week dosing more in order to, again, mitigate those risks, just given we don't have a lot of data on this one. So if we were doing that 23 milligrams per week that we calculated, that would be about 7.5 milligrams 3 times per week, with B vitamins on the other days. However, given anecdotal reports of benefit at doses of only 5 milligrams 3 times per week, I like the idea of starting there before going up to 7.5 only if you need it. And based on MOTS-c's mechanism, again, you'll likely still receive benefit if you even needed to do less frequent dosing due to cost, i.e. doing 5 milligrams only 2 times per week. This will likely still provide some stress signals which will result in positive adaptations, although maybe just less positive adaptations than you would receive with higher doses or more frequency. But obviously none of this is being done currently given the current FDA ban, but if it were done in the future, doing it in conjunction with regular lab work and discussion with your doctor could help you find the best cost-efficacious and safe dosing schedule for you. But does it matter when in the day you inject your MOTS-c? Well, given the synergistic effects with aerobic exercise, it would benefit you actually to inject this one 30 minutes prior to starting your aerobic exercise. This is how multiple mouse studies administered the MOTS-c when looking at MOTS-c's synergistic effect on exercise. So to me, this is the most important timing consideration. Then outside of this, injecting MOTS-c in the morning also might give you some additional benefit. This is because mitochondrial function and AMPK activation are tightly controlled by the circadian rhythm, and they are increased in the morning in order to meet the increased energy demands that come in the morning due to now being awake. So by aligning your MOTS-c administration with the circadian rhythm, you may be further optimizing its effect. But this is yet to be directly studied yet, so just theoretical here. And finally, how long should you cycle on MOTS-c, i.e. how many weeks of 3 times per week dosing? Well, again, this is all speculative due to really limited data, but the main goal here is to cycle on long enough to gain meaningful benefit, but short enough to mitigate the risks we've talked about or any unknown risks that we're unaware of right now due to limited data. And truthfully, this discussion is different for everyone based on your age, current mitochondrial function, or just what you're using it for. However, for general anti-aging or exercise adaptations, I like the idea of starting with a 4-week on, 4-week off cycle. And this type of cycling is basically based on the principle of hormesis, or again, that coming back stronger mechanism after a stressor. Essentially, the 4 weeks on allows for adequate stress signaling from MOTS-c to start to trigger your cells to adapt to hopefully eventually come back stronger. And then the 4 weeks off allows the mitochondria and the cells enough time to fully adapt, recover, and provide that lasting benefit. But again, this is very hypothetical given no real human or even animal-based studies looking at cycle lengths of MOTS-c. It's fully just based on the mechanism of hormesis and the mechanism of MOTS-c, along with anecdotal reports of the use of MOTS-c. But because of limited evidence, even if this one were to be FDA approved, I wouldn't just go cycling on and off it indefinitely. Rather, I'd work with your doc to really use MOTS-c sparingly to fully optimize your lab markers and your exercise adaptations. And And then finally, just briefly, a quick aside on sourcing. Because you can't get this one legally from compounding pharmacies right now, I'm staying away from it, as I really do not trust online research use only suppliers. But because I know many of you are still going to get it online, I would implore you to go look at our BPC 157 video and watch the end of it, where we discuss how to make online sourcing as safe as it can possibly be. So once you've done that, check out our other peptide videos here, and also hit that subscribe button for the top 5 peptides for longevity coming soon.